How's it going, everyone? I wanted to make a new vlog updating my progress on Toy Engine in the last few days. Specifically, I was wanting to show the addition of uniform buffer objects and the scene graph. Overall, the test scene doesn't look too different from my previous post, but you'll see over here in our UI options, we now have translate root and translate cyborg. Basically, these are for testing testing the scene graph structure that we've created. So you can see here, translate cyborg does just moves the cyborg model by itself, which we had working before and works using transformation matrices. So here we can translate it and rotate it as we were previously doing. The addition is that now both our models are nested under a scene root. Using this control, we can now translate the scene root, and we can apply any of the translations. So translate, rotate, scale, and skew. And you see that the transformation is applied to all the objects and all the models in the scene, which is cool because we're only updating one transformation matrix, and then that is getting propagated down to the child nodes in the scene graph. Looking up here, you can see the structure of the current scene graph. So right now for our test scene, things are pretty basic. We have a scene root node, and then we have our two models. So this control here changes the translation of this scene root node, which then gets propagated down into the backpack model and the cyborg model. The other change we made was the addition of uniform buffer objects, which doesn't have any visual or functional change. But now instead of sending lighting data to the lighting and camera data to the GPU through several different OpenGL calls, we're now sending all that data together as a single byte array. So let's get into the code and show you what's changed. So looking over here in our example scene, we can start off by looking at our scene construction. So if we come up to on attach where we're creating the scene here, we can see that we're making a new unique pointer to a scene node. So scene nodes is what every object in this scene is contained in. So in our scene node class, we have basically a local transformation and a world transformation. So the world transformation contains all the transformation of all the parent objects combined together. And then we have a list of children nodes and a pointer to a parent node. And so this structure allows us to propagate down transformations from parent nodes to child nodes. So kind of most of the work here is being done by update world transformation. So we have kind of standard functions like setting the parent node and adding a child, adding a node as a child to a parent. But in this update world transformation is where kind of the magic happens. We have, I don't know why those tabs are that way. I'll fix that later. But here we can see that when we update the world transform of the current node, we first look to get the world transformation of the parent if the node has a parent, or else we just apply the local transformation as the world transformation. Additionally, we're using a dirty flag, which basically means that the dirty flag gets set when changes have been made to the scene node's local transformation. And in that case, we're going to need to propagate that local change down to all the child nodes. So here we look at it and we say, okay, the local transformation of this node has been updated. So now we need to go ahead and update all the child node world transformations. And you can see here we're making a recursive call so that it propagates down through the entire scene graph node tree there. And here you can see how we use the scene graph system. We we create a root node, and then we add child nodes to that root node using the add child method. Each we're using unique pointers because we only want one pointer. We only want the parent node to own the child. All right. So that's the scene graph. And now let's talk about the uniform buffer objects. So this is really great because it allows us to send um, data that gets reused a lot over in one call. So you can see in draw scene, if we look at begin scene, so in our renderer, so when we begin a scene, we send the camera data and we send the light data to the renderer. And in our renderer, basically we just set the uniform buffer object to this updated camera and light data. And this data lives in memory on the GPU and can be accessed by every shader. All shaders can access it. And they can access it by using a uniform layout over here. So over here, as long as we use, and then keep track of it through binding points. So here you can see that the name view project max is the same as what we have over here in our Phong shader. And we have something very similar, layout light block, for sending our light data to the fragment shader. Uh, Kind of the tricky thing about this is how the data is sent in the alignment. You have to structure your data very specifically to meet this STD 104 standard that specifies how the data gets laid out. Because when it gets sent over, it's just byte data. So you have to send it over and then in your shader, tell it what that byte data actually means. So you have to say, okay, like for instance, our lights are a total of 80 bytes get sent over for each light. So then over here in our shader, we have to specify like how those bytes align to different variables so that then we can use them in our main shader. So that was kind of the tricky part of working with these uniform buffer objects is structuring the data so that we can send it over in a single call. In the renderer, let's see, render.cpp, you can see, so here to send the data, we just specify the offset, which in the case of our light uniforms is 0 since we're just sending the entire block of data as one big thing, and then the size of the data and a pointer to the data that we actually want to send. Creating it actually just like creating any other sort of buffer object in OpenGL. I'll go into that here in our, oh yes, in our renderer. So to create the buffer, um, oh yeah, I'm using a buffer manager. So this keeps track of which bind points are available for our uniform buffer object. So this one creates the buffer, and here is we actually go in and create our buffer object, and we have it set up so that it's abstracted, and we can have different specifications for different rendering APIs. In the case of OpenGL, we have it's just basically the same as creating like a vertex buffer or an index buffer. You just call uniform buffer, send in an unsigned integer that then gets assigned to that buffer ID, and then you use that buffer ID whenever you want to work with that specific buffer. So yeah, that's pretty much the updates I wanted to share. I just wanted to talk about my work with uniform buffer objects because that was a real improvement on how I was sending lighting and camera data to the GPU instead of, making an OpenGL call, like an OpenGL like send mat4 call, right? Instead of making a call like this every single time to set a GL uniform variable. Instead, now I can just send all that data over in one call as a big block of byte data. So that was I think a real improvement and how I work with light data. Moving forward, I'm going to get into more advanced OpenGL and lighting techniques. So with the goal of implementing PBR or physically based rendering in my um, game engine, because right now it's all based on Phong shading, which is a pretty basic method. So I like to work with and learn about more modern rendering techniques. All right, that's all the updates I have. Thank you.